Welcome to a maths lesson all about probability. The question we have to ask ourselves is, can mathematics help us to predict the future? Well, what do you think? I think it's worth exploring, so let's go and have a look at what we're going to be doing in this lesson. Have you ever thought about, is it possible to see into the future? That would be amazing, to be able to recognize that something is going to happen before it actually happened. But is it possible? Well, people have dreamed about it for many years, but we're not sure that it really is possible. There's a big question mark around that. But what are the chances that you can guess or calculate the result of a soccer match? Well, if it's a certain soccer team, well, maybe you can look at what has happened in the past and from that try and make an estimation and predict what might the result be. But of course, there are always surprises and upsets, and even the team that wears yellow and black, they can lose sometime, or that other team that wears red, it can also lose sometimes. But you never know what's going to happen until it actually happens. And so this is the area of mathematics where we think about chance and what could happen. We call this idea probability, making some predictions based on some data. There are two things that we're going to look at today: the theoretical probability and then doing some exercises, some experiments. And you know, I love doing experiments. So let's just go and have a look at these. So as I said to you, there are two ideas we're going to be looking at. The idea of theoretical probability, how do we calculate it? And then doing some probability experiments. But before we get into those, let's have a look at some key words. We've spoken about the word experiment. An experiment in this context has a very particular meaning. It's an activity that is uncertain. We're looking at an activity where results are uncertain. The outcome of an activity or an experiment, that's what the result is. Now, let me be clear about this. If we're doing a whole lot of experiments, and these not necessarily throwing chemicals into a beaker and hoping for something to explode, but this could be a simple experiment of rolling a dice or flipping a coin, or it could be picking up numbers out of a box. All of those are experiments. The result of what we see at the end of the experiment, that's known as the outcome. It's also sometimes called an event. Right. Now, of all the events that take place, some of them might be things that we would like to happen. Some of them might be things that we don't like happening. So we have things that are called favorable events, those that we like to happen, and those that are not so favorable. We're not interested in those. So let's just recap there. Favorable events are the ones that we want. The outcome can be all the results. Okay. And we're interested in being able to look at the relationship between all the results and those that we really want to happen. And that's what probability is all about. Trying to establish the relationship between what we would like to happen and of considering all the possibilities of what could happen. Let's make it clear. And so in our definition here of what probability is, we're saying probability is the percentage chance of a favorable event taking place, or in a favorable outcome or desired event taking place in an experiment. So be very careful about how we're going to represent this. We can represent it in different ways. Here is one particular way of representing what probability is about. We can say, of all events that we're looking at, some things are impossible. And then they have associated with them a probability of 0. So say, for example, if we had to think about some events like, let's celebrate Christmas on the 26th of December. Well, we'd say, no, that's impossible. It doesn't happen. Nobody does that. It's impossible. Perhaps even more impossible is if we thought about the event of the sun not coming up tomorrow morning. Well, we might not see the sun, but the sun will certainly come up tomorrow morning, as sure as anything. It's impossible for the sun not to come up. So I could say the probability of the sun not coming up is absolutely zero. On the other hand, I can say it's absolutely certain that the sun is going to rise tomorrow. I'm absolutely certain that on the 25th of December, the majority of people around the world are going to celebrate Christmas, because everybody sees on the calendar, the 25th of December is known as Christmas Day. And so it's not another day, it's that day. And so the probability of Christmas happening on the 25th of December is going to be said, yes, it's absolutely certain. It has a probability of 1. But you see, in between 0, the impossible, and the certain, there's a whole lot of question marks. And that's where we explore in probability experiments. So what's the probability of me flipping a coin and getting a head or getting a tail? Well, it's probably 50%. It's halfway between 0 and 1. Because there are only 2 outcomes. It could either be a head or it could be a tail. It's in the middle. We would say it has a probability of 0.5 or a half. And so as I've indicated there, here are some examples of probability experiments. I've already spoken about flipping a coin. Rolling a dice is another one. Picking up a card from a deck or using a spinner. Now, later we're going to actually see what a spinner is. This isn't a fidget spinner. No, I'm not giving you permission to play with a fidget spinner. This is a needle that is placed on a card that can spin freely and rotate, and it can stop at different points. We can have different segments around which it stops. We're going to do a very simple one and look at the probability of it landing on a certain colored region. All of these are experiments, and we don't know what the outcome is going to be until we've actually done them. So don't get lost. Stay with me as we explore some probability experiments. Now, when we do this idea of probability, we've got to have some notation. And the biggest thing we're going to talk about in this little section is the idea of a sample space. And it's given a symbol S for sample. And it tells us it's all the outcomes are resting in the sample space. So everything that we're going to think about is there in that sample space for that experiment. It doesn't mean that we think about other experiments. We define our parameters very carefully and we keep them contained. So if we're throwing a dice, then we would say, what are the possible outcomes? What are all the possible outcomes? Well, we recognize that the dice is a cube and it has 6 sides to it. There are only 6 numbers. So the dice can either be a 1, a 2, a 3, a 4, a 5, or a 6. That makes up the sample space of the possible outcomes for rolling a dice. As I've said to you, flipping a coin, there are only 2. It's either heads or tails. Now, let's have a look at the next idea. What are the favorable outcomes? Now, this is your choice. You could decide that the favorable outcome or favorable event that you get really excited about is if you're playing a game and you roll a dice and it lands on 6. That's the one that you get excited about and you want to shout, yay, I've got a 6. I've managed to get the thing that I wanted. That's a favorable outcome. We recognize that the total number of favorable outcomes is represented by this notation. Favorable is the number n in brackets f, where the number of all the possible outcomes is given as the number, and then in brackets we have s. That s relates to the sample space. The f relates to the number of favorable outcomes. So if we are going to define and calculate probability, then we recognize the probability of a favorable outcome is actually defined as follows. It's the number of favorable outcomes possible. So maybe it's not that we just throw a 6. Maybe it's that we throw a number greater than 3. So it could be 4, 5, or 6. And out of all the possible outcomes, we can then say the probability of the favorable event is the number. Please notice it's not probability, it's the number of favorable things divided by the number in the sample space. So this is a very important formula and one that we're going to use quite often. And so what I want you to understand, in dealing with that particular equation or that calculation, there are more than one way of representing the probability. We can represent it as a percentage. We can represent it as a fraction. And that could be a common fraction where we say it's 1 out of 5, or we could say it's 0.2. It's still a fraction. So we can represent probabilities as a percentage, as a fraction, and here's another one that is very commonly used. We can represent it as a ratio of two things. Have a look here. We're saying it's a percentage, a fraction, or a ratio. So say, for example, my fraction was 1 out of 4. That is saying the ratio of the probability of a favorable thing happening out of the 4 possible events means it's 1 to 4 in a ratio. If we would convert that to a percentage, we would say that would be 25%, because it is equal to 0.25. So those are the ways of representing and measuring probability. I want you to make sure that you don't get confused in terms of, oh, it's always got to be a percentage. No, it doesn't. It can either be a fraction, a decimal, a common fraction, or a ratio. It's all about the chance of something happening. Now, obviously, the closer that probability is to 1, if it's a fraction, the more chance, the more certain it's going to happen. The closer it is to 0, the less chance it's going to happen. So we need to be very clear and make sure that we understand when we read a probability what that's telling us, that we are certain or not so certain of something happening. I'd like to do a quick calculation with you, and I'll do a little experiment so that we can make sure that we've got things in place so that we can build on this. And so in my example, what I'm going to say to you is, if in a bag I have 6 black socks and 2 white socks, what is the probability of selecting a black sock? What's the probability of selecting a white sock? Well, you know what? We don't just talk about these things. We've actually got to do them, because probability is all about experiments. And so in this bag, look what I've got. I've got a white sock and another white sock. That's 2 white socks. And over here, count with me, that's a black sock. That's 1, 2, 3, 4, 5, and 6 black socks altogether. So into this bag, and I'm going to show you, there's nothing else in the bag. There's nothing else. You can see the bag is completely empty. Now I'm going to put these socks back into the bag, and what I want you to think about is, what do you think the probability is going to be of pulling out a black sock? Do you think it's going to be high or low? Let's have some fun. Let's predict. Well, what's the total number of possibilities that I could have? Well, I could actually have either a black sock or a white sock. So, in effect, the number of socks that I've got in the bag here, I could pull out 6 black socks, or I could pull out 2 white socks. So the total number in the sample space is 8 possibilities. And out of that, Let me see what I'm going to get. The number of black socks. Oh, there we go. There's a black sock. Why? Well, because there were 6 out of 8 for the black socks. So if I was to think about the probability, the total number of socks is 8. The number of socks in total is 8. The number of black socks is 6. So it's 6 out of 8, which is 3/4. So it's a 75% probability of choosing a black sock. Whereas out of choosing a white sock, there are 2 white socks. There are 8 socks in total. So 2 out of 8 is 1/4, and that is equivalent to 25%. Well, I hope you got that prediction right, and perhaps get your bag and see if it works. Ah, there's a white sock. Aren't I clever? I got it, just even though I wasn't sure it was going to happen. Don't be shy. Go and play a little bit with some probability and take a little break, and we'll be back to explore this a little bit more in further detail.